Hello, everyone. You know what? It's the afternoon. It's after lunch. Can I get a little bit of noise, like maybe an AI or like just a grunt? Can I get something? Yeah. All right, cool. I really appreciate everyone being here. Welcome to Build Day 2. I know that Day 2 is not quite Day 1, but the secret is that the most knowledge comes on Day 2. The hype is Day 1. The knowledge is Day 2. So, with that being said, my name is Andy Beatman. I'm Director of Azure OpenAI Service, lead product marketing. But we have a special guest today. I do have two colleagues with me, Mark and Kamala from AKS and Cosmos DB. But here's the thing, y'all. The focus today is on our customer. The focus today is on TomTom. Now, you might be thinking, TomTom. I bought my parents a TomTom navigation device in the early 2000s. That's true, you did. But here's the thing about TomTom. They've been powering the auto industry for decades. And what we're going to learn about today is the TomTom Digital Cockpit, something that any developer here can customize for your auto company. So, with that being said, I'd like to make some noise for our special guest, Masi, data scientist from TomTom.
All right, thank you so much. Can we switch this to the slides, please? There we go. All right. So what is this AI app we built? And how do we do it? Well, to tell you that, I'm first going to have to tell you a little bit about who we are as TomTom. Essentially, everywhere where there are location services or mapping needed, there is TomTom. So for you developers, that actually means that we are a place to get APIs and SDKs for all your location tech-related needs. So you can think about showing maps on your website or in your apps, geocoding some address data for your analytics, or creating some routes, maybe all the building blocks that you will need for your APIs, for your apps if you're building anything related to locations. In any case, I'd urge you to check out the developer portal to find these. But let's get to business. What do we build? Well, modern connected cars, they need a digital cockpit that includes a lot of location-related tech. And we offer a platform to allow car makers to develop such cockpits. And when we saw conversational AIs, like ChatGPT, come onto the scene, we asked ourselves a question. What could conversational AI mean in a car? Now, we already had some experience integrating with various voice assistant technologies into this platform, so we knew a thing or two about this. First of all, you'd think that voice interaction should be much safer than typing on your car's screen. But it turns out that it can be pretty hard to stay focused when your voice assistant doesn't understand you. And even some basic tasks like finding some open restaurants or maybe changing some car setting can be pretty daunting when you're not understood. And you might recognize that feeling. You usually have to be pretty explicit to your car if you want to make it do something. Lastly, so drivers also still have some trouble understanding some of the really advanced features that are hidden maybe deep in some menus, and you're certainly not going to change those while you're driving. And I think a lot of good features go unused because of that. So it turns out that generative AI is actually a game-changing enabler to build much more conversational assistants. And this really comes down to how you build them and really whether you're understood. But let's stop talking and just show you what this was. Let's cut to a demo. Hey, I'd love to visit the racetrack later. What's it called again?
The racetrack is called Circuit Zandvoort.
Awesome. I'd love to go there. Can you help me find a charger nearby?
I found several EV chargers near Circuit Zandvoort, including Community by Shell Recharge, EcoTap, and Charge Now, all within 1 kilometer.
Great. Please route me to that first one and also turn up the temperature just a bit.
The first EV charger near Circuit Zandvoort is at Community by Shell Recharge, Burgemeester van Alphenstraat 108, Zandvoort. I've also turned up the temperature in the vehicle for you.
Thank you so much. So I bet you're aching to learn how we got there, because we actually got started pretty early in 2023. when this was much less obvious than it might be now? Well, let's start one step at a time. Let's start with the ingredients. So the motivational thing for us was to see, ChatGPT. We thought, can we put that in a car? So clearly, we're going to need some kind of LLM for a brain. But a brain in a vat is really only so useful. So we're going to need to be able to talk to it. It will need some ears and a mouth. So these are ASR and TTS engines. Remember, this is pre-multimodal AI. So to roll down the windows or plan a route, you're going to need to give it some hands. Any kind of mechanism to be able to make it do stuff in the real world. So you can think about rolling down your windows or planning a route. Now also, a conversation with a goldfish is absolutely no fun, so you're going to need to give it some kind of memory. And that's a clear need to manage conversational state in some form of database. Lastly, this brain is pretty good as a reasoning engine, but it might not have the same knowledge that you want it to have. So rather than fine-tuning, we actually decided to go for some more dynamic knowledge approach, retrieval augmented generation. Well, this is featured in every other talk now, I think, here. So let's match these ingredients up to some bricks in Azure. We mostly go with off-the-shelf Azure components just to get started, just so that you can really focus on the core concept, the core idea that you want to test. And then, from then on, you can iterate towards the product. So for the brain, we went with Azure OpenAI, but other instruction-tuned models would probably have done too, to test the concept. What I like especially about how we did this is that we got started just with prompt engineering over fine-tuning, which gives you much better iteration speed in the beginning, I think. Now, for the ears and the mouth, just rest assured that there are some Azure products that you can take off the shelf to fix that. For the hands, well, this and wiring everything up together is really where the rubber hits the road. And you will have to do the work to differentiate here if you're building something like this, so a text or a voice app. Next, for the short-term memory, we went with Azure Cosmos DB, because adopting a NoSQL database can really help, again, with the iteration speed. No schemas, it helps sometimes. And for the knowledge, Azure Cosmos DB and Azure AI Search are actually the ingredients to build a semantic knowledge base for your app, because they offer vector search capabilities. So we ended up with something that looks a little bit like this. And what I want you to take away from this here, on the left-hand side, you see what's happening in the vehicle. Of course, if you want to roll down the windows, you need to integrate that on this client side. But most of the clever stuff happens in the cloud here. What I want you to take away is basically we put together a lot of Azure bricks as starting points, again, so that we can focus on the core concept that we want to explore. And for us, that was how do we integrate with our services so that we can differentiate. So putting all of that into your POC all at once, not a great idea. What is the concept that we want to get started on? For us, the core technical concept was connecting this brain with our services. Right now, you might say, like, that's pretty obvious. You just use some function calling, some plugins, blah, blah, blah. But actually, none of that existed at the time. So it was not that obvious. So our hypothesis was actually that we can hook up DaVinci GPT, for those of you who remember what that was, to TomTom services using the React prompt. So what is the very tiniest way that you can test this idea? You go to the Azure OpenAI Playground, make a prompt, and see if you can make it do the thing that you want at least once, just once. And then you make it a bit more credible that this is something you want to explore further. So that's what we did. So now, here to tell you more about some exciting announcements for Azure OpenAI and what you can try out in the playground, here's Andy again.
I don't want you to go anywhere, so stay here, right?
I'll be
because
here.
we've announced a lot of things, and these things that have come out, in my mind, has changed the way that you may have approached this POC. So what I'd like to do is share some of those new announcements, but get your live reaction. I love live reaction videos on how you would have thought about this new innovation in building the digital cockpit, because things like GPT-4o, you know, it just came out, and I know you're excited. So in a way, it could change the impact of this solution. So, can we bring slides back, please? Or actually, let's keep it going. Thank you. Using my hands, my brain, my mouth.
There you go.
All right,
like an
cool.
AI.
Yeah, so exactly. So what I find interesting is, and for me, I've worked on Speech API, Vision API, and now Azure OpenAI Service the last few years on Azure AI team. So hearing the way that you've leveraged our classic services like speech and vision are amazing to see. In fact, I think the speech to text capabilities are some of the best in the world. So I love that you're leveraging it. Now, here's the thing though. When in this architecture where Azure OpenAI Service is coming into play, we have this long list of new innovation that came out just this week. So I want to just focus on a few because we're not going to talk about fine tuning. I know that that's something that you all have looked at, but you've figured out, I'm going to quote you, you've prompted your way out of trouble. Maybe fine tuning would be the next step. But we also have the new GPT-4o. And also you talk about the OpenAI Studio. We GA'd the Azure AI Studio this week as well. So there's a lot of things that I think could have an impact on the way you're approaching the work. So really quickly, a year ago, we would just have on this screen GPT-3 and Codex, rest in peace. Now we've obviously evolved the GPT family. We've brought in image, speech models as well. And of course, we've created new ways like assistants and on your data to go bigger. So what I'd like to know from you, Masi, GPT-4o, we just made that GA just yesterday in the nick of time. How are you thinking about the newest model, the newest advanced multimodal flagship model from OpenAI?
Yeah, sure. Well, I watched that big reveal, the super impressive reveal, live from the hammock. And I could try it out like within the hour. So that I absolutely loved. You can imagine that immediately the questions come in, when can we have this, right? So when can we have this?
I texted Sam Altman just before this, so
Oh, yeah?
I'll get back to you shortly.
All right, cool. So, but I think the main thing here is voice bots are just going to get way more expressive, understand you better, and it will improve the general experience because it cuts down on latency of using the ASR and the TTS engines that you actually wrap your text-based bot in.
Now, your demo was great, and the audio processing was fast, but there's a world where you could interrupt, right? And you could have a more natural conversation with the car.
That's right.
Okay, cool. Now, let's talk about fine-tuning for a second, because fine-tuning has been highly requested by some major enterprises. You have a small, lean team, but a smart team. So how are you thinking about fine-tuning, especially with fine-tuning for GPT-4 and even pre-announcing fine-tuning for GPT-4 Omni?
Yeah, sure. So I think fine-tuning doesn't always have to be the first thing you jump to. So if it's just about incorporating your own knowledge, you should probably try out RAG first. But there's definitely situations where you're going to need this. So for instance, if you want to make everything faster, you go for a smaller model and you carry over maybe the outputs from your big model, fine-tune your small model with that. But also at some point, you might not be able to prompt engineer your way out of trouble anymore if it's not doing what you want. And I think that's a clear sign when you need to start fine-tuning.
Now, I don't have a Phi 3 slide, but I'm also thinking about those times when the car is in a tunnel, you lose access to connectivity, and you need to run the local inference. So maybe something that you're also thinking about with the SLMs.
That's right.
Okay, now, finally, we have the Assistance API. Now, the Assistance API, in other words, is agents. This idea of personal agency, this idea of using agents to extend your Copilot. So how are you thinking about assistants and agents when it comes to the in-car experience?
Yeah, so specifically the Assistance API, I'm like pretty jealous of the people who are doing their POCs now versus then, because this is like a clear shortcut to having some of these ingredients just straight out of the box, right? So the conversational memory, the integrations that are much easier to do, you simply supply your function specs and that's it, I think. So pretty jealous.
Well, you still have access to it, so.
That's right, but I think, yeah, all right.
Well, it's like in the US, the president cannot ask for a salary increase. He has to request it for the next president. You get to be the next president.
That's right.
Okay, cool. So I'm really excited about everything that TomTom's done. I think for me, we're at Build, right? So if you're a developer and you're working in auto, you can go to the developer portal on TomTom and you can really take advantage of this for your automaker. I'm really inspired by all the work, so I'm really thankful. I'm gonna give you back the mic, but I'm really happy that we could kind of look into the future together. I think the pace of innovation in generative AI is blistering. I think most of us are used to one SDK update a year, maybe a few features, and I know on Azure OpenAI Service we've launched 16 things since January 1st. So I really appreciate all the way that you're innovating. I'll be back shortly, but thank you again, Masi.
Sure, thank you. Can I have the clicker? Thank you. Thank you so much. So we go back from the future to the past. How did we develop this app? So we were stuck in the playground. We proved the concept that we can do it at least once. So what's the next step? The approach is, of course, we iterate and we keep iterating, every time proving the next concept and making it easier to get feedback. So given this was early 2023, LangChain 0.0.0. something had come out a few weeks before that, and it provided a really nice starting point for us so that we could replicate what I did in the playground in an app. Awesome. So now we actually have the brain connected with our core skills, which allows some simple interactions. But it only works on my machine, and that's only so useful because we want to get a lot of feedback from colleagues and potential users. So allowing for more iterations, maximizing learning, you need something that's kind of shareable and usable by other people. So time to bring this to the cloud and let our app grow up just a bit more. So using an example repo with Bicep templates, it instantly gave us some infrastructure as code. And honestly, I surprised myself that I could work with this because I had never done infra as code. What I find pretty cool is that's the moment I found out that GitHub Copilot plus VS Code are pretty good at Bicep templates. So to tell you more about how we did this with AZD and infrastructure templates, here's Kamala.
Thank you, Masi. Well, it's really great that you and your team were able to actually get your app going and started with the Bicep templates that we provided as part of the open source library. And just like yourself, lots of customers are looking for how to rapidly adopt AI capabilities. And after all of the AI and the data work that teams are building comes to life within an application. So to that end, we have been building and open sourcing extensible, customizable application templates that include everything that a developer needs to get an application up and running. And that includes, whether it's code, infrastructure as code, and obviously these are more than Hello World applications, and have the editor configurations, pipeline definitions, and much more included in there. So the templates are on GitHub and organized by language or hosting platform, and you can select depending on where you're running them. And they can be modified, so you yourself can contribute templates as well, so that others within your organization can actually build on the work that you've already put in. I encourage you to check it out, and we'll share some resources with you towards the end too. Now these templates, they work together with the Azure Developer CLI. This is an open source tool where we are connecting many of the code to cloud experiences. As I mentioned before, the application code, the editors, infrastructure as code, as well as the pipeline. Our goal is to provide a fast and streamlined path from any developer's coding environment into Azure and pave a path from getting started, like a POC, and into production. We have many options on Azure. It's a full-service cloud, obviously, and has many options for hosting intelligent applications. So we think about our application platform as a continuum of many layered and connected services, where customers will be able to choose the service that makes the most sense for their organization. And that might be, if you're a team that prefers a very opinionated platform, like a platform as a service or a PaaS, you may be in a team that might be coalescing on something that's more open source oriented, and along with the cloud native ecosystem like Kubernetes. And we have both options available there for you to get started. We're finding that Kubernetes actually is a great platform for building intelligent applications, and actually combines a lot of capabilities for doing machine learning operations as well. And of course, the platform really has evolved over the years to be quite versatile, right? And in the enterprise, as well as in smaller companies, like OpenAI, if you can call it small, and supports a variety of application architectures, not just microservices anymore. And because of this flexibility, the adoption of Kubernetes in the enterprise is often the centerpiece of a much broader modernization initiative, which occurs simultaneously with containerization, microservices-based architectures, DevOps tools, and the adoption of CI/CD practices within the enterprise as well. So there's a lot going on. And so to that extent, you might have seen in today's demo that Scott did during the keynote, how GitHub Copilot was providing a guided workflow for those who don't have prior experience with the best practices kind of built into the product. Symmetrically, on the Azure Kubernetes side, we are enabling developers to go directly from GitHub Copilot, and their favorite dev tools to get started on AKS, Azure Kubernetes Service, regardless of previous Kubernetes experience. Now, short of a drum roll, we are introducing AKS Automatic to make AKS experience even more productive for developers and operations teams who don't have platform engineering experience in a way that they can make their developers self-service. So AKS Automatic offers this experience and makes the most common tasks on Kubernetes fast and frictionless, and of course it also preserves all of the flexibility and the extensibility and the consistency of the Kubernetes with the upstream Kubernetes that people have come to rely on. So operational and the development best practices that one needs in order to get started have been formalized into the product. And there we've actually harnessed some of the experience that we've developed ourselves, running some of the most advanced Kubernetes applications in the world. And this includes applications like Bing, Xbox Online Services, M365, GitHub Copilot, you name it. A lot of the Microsoft crown jewels run on AKS. So it automates everything to be production ready from cluster setup and management, and takes care of things that you normally wouldn't necessarily know that you need to take care of when you're getting started, like performance, security safeguards, enforcing them, setting up policies, so that your developers can actually go from code to Kubernetes in minutes, without giving up the ability to use the Kubernetes API and the ecosystem that's built around it. So if this is not your jam, there's always AKS Standard, but if this is your jam, we're very excited for you to try it. Back to you, Masi.
Thank you very much. I have my own mic, thank you. Thanks. So I'm no infrastructure expert, so AKS can be a bit intimidating for me maybe. But so TomTom has adopted AKS, so I'm sure my colleagues will actually love this news. In the meantime, let's keep building out this assistant app. And the next step, as I mentioned before, is to add some knowledge and some memory. So on our laptop, we can totally get away with in-memory conversations. But when we go to a cloud app, we should really add some kind of database to store that. So we added Azure Cosmos DB, and I think it was even in the template. But apart from conversational memory, we also added some vector search magic so that you can talk to your car's manual. Now, if you're developing a similar chat or voice assistant, what will you have to think about when you add this to your app? So when it comes to memory, as the conversation length grows, you're going to have to make some trade-offs. Especially for voice, the response time is really important. So some tips here are just manage your context size, so the tokens that you actually expose the model to, actively. Some of the frameworks can help with this, so to trimming it dynamically, for instance. You can also maybe think about having some time to live for the conversations, or there are many clever tricks around. For the knowledge, first of all, I'd like to, again, bust the myth that for an AI to use my data, I need to train on it. Instead, you can just search your knowledge and inject it into the context, aka retrieval augmented generation. Here, the tricky bits, or what you should spend attention on, is how you ingest it, so especially how you chunk large documents, and then how you present it. Will you summarize things before you expose it to the model? Now, in any case, Azure Cosmos DB is pretty much the natural home for memory and for knowledge. And to tell you more about how Cosmos DB can help power your AI app, here's Mark to tell you a little bit more.
Thank you, Masi. For TomTom's digital cockpit, managing knowledge and memory is critical to its success. And Azure Cosmos DB has been helping them to bring their innovations to auto manufacturers for the next generation of cars to consumers. Since the emergence of ChatGPT in late 2022, Azure Cosmos DB has been playing a quiet yet significant role in the Gen AI space. And this includes being the database that powers ChatGPT that you may have seen this morning. That's allowed OpenAI to grow to 180 million daily active users for ChatGPT, faster than any other app in history. And they've done it with just a single Azure Cosmos DB database that scaled out automatically as the number of users grew. And today, the role of Azure Cosmos DB is going to grow even more. We're pleased to announce the preview availability for native vector search for Azure Cosmos DB for NoSQL. In an industry-first release, Cosmos for NoSQL has now combined its capabilities as a high-volume NoSQL OLTP database with vector indexing and search in a single service. This combination of transactional and vector provides drastic reduction in both the cost and complexity of your applications. It also combines the power for transactional and vector queries, allowing you to simultaneously combine equality, range, and even spatial filters into your vector queries. And this improves the performance and reduces the cost of your applications. And this performance comes on top of the most powerful database in all of Azure, with industry-leading SLAs and, in another industry first, a full-featured serverless offering for users. With these capabilities, new possibilities for building Gen AI applications, combining operational and vector data in a single database eliminates the need to have to ETL that data into a single-purpose vector database. This is reducing complexity and cost for users. Building RAG pattern applications now gets even easier and also enables the possibility to build mission-critical and real-time workloads for your Gen AI applications. Now, Cosmos DB has always been a favorite for customers to build chat-based applications. With this vector search capability, users can now take that to the next level to improve that experience for users. And finally, it enables new innovations such as semantic caching, which drastically reduces the cost and improves the performance even more. However, we're not done yet. Cosmos DB is known for its performance and scale, and we're going to take this thing even further, which is why we're pleased to announce the preview availability for Disk ANN for Azure Cosmos DB for NoSQL. Disk ANN is a new and innovative technology from Microsoft Research and takes vector databases to new levels of performance and scale not possible with any other vector database in the industry today. Let's take a quick look at how Disk ANN works. So here I have some documents with both a mix of regular JSON data and then vector data in here. Now, as I write this thing in, what happens is the JSON data is going to get written into the fast SSD storage built within Cosmos DB. This is all on-cluster storage, and it's how, or at least one of the reasons why, we can provide single-digit millisecond latency for reads and writes within Cosmos. We, of course, also are going to index that data into our B-tree index as well. For the vector data that goes into this thing, two things also happen. We're going to write this all full fidelity vector data into a graph structure that's also stored on our fast SSD storage. And I'll also build an in-memory index of quantized or compressed vectors that also sit on top of that. For the read path here, so if I want to write a query that's going to query this data in here, what happens first is the query is going to consult this in-memory index for those quantized vectors and then get addresses to where that data sits in the full fidelity graph sitting here below. And then grab all that data and then send that back to the user. So There's lots of advantages, of course, for DiskANN for doing these vector search applications. Vector databases in market today are all built using HNSW and run in memory. To grow large, you need expensive optimized VMs, and there's practically a limit to how big you can grow with these things. The in-memory index compressed vectors with the full fidelity graph of fast SSDs provides very low latency. And the graph simultaneously is going to help you provide high accuracy at very large scales. Additionally, unlike HNSW, DiskANN's index does not degrade over time with large data changes, making it perfect for generative AI applications that are built over transactional workloads. And the biggest advantage comes with what Cosmos DB is really famous for, and that is just massive scale. Cosmos DB is a scale-out database, and this allows us to grow to sizes that are just not possible with any vector database in the market today, able to support hundreds of billions of vectors or trillions of data points. And best of all, you can get all of this scale at much lower cost than what you could ever achieve with any in-memory vector database. And finally, DiskANN is proven technology. This is not brand new. Bing Search is using this now as part of their search engine, and also a suite of Office services as well is using DiskANN to provide vector search today. So we're very proud now to offer this amazing capability to users that are building generative AI applications and services. But we're not done yet. Lastly, users building these Gen AI applications are overwhelmingly using the new crop of these LLM orchestration SDKs to go and build increasingly complex LLM workflows and AI agents. So today, we're also very proud to announce integrations for Azure Cosmos DB for NoSQL vector search for both semantic kernel in both C# and Python, as well as in LangChain for Python and Java. These new integrations are going to provide the flexibility for building generative AI applications using these new integrations or native SDKs or a combination of both. So Masi, I hope that sounds great to you, and I hope you're excited for the next generation of TomTom and the in-car digital cockpit. So thank you very much.
Thank you. All right, so we're on the home stretch. It's time to get prod ready. So because real value is only really achievable when you can reach real users, of course. So that means that you are going to have to integrate into some new or an existing product. So this is really a time, this is the last moment you can do all of your quality evaluation. And this is an emerging field, I think, quality evaluation for such applications. You can think about complications like outputs can be a bit random. How do you deal with that? If you have an AI checking another AI's output, that's even more random. So we also felt forced to ditch LangChain, but that's really just because of the timing. We were a bit too early. And then, we need to manage the memory more actively, add some longer-term memories, for instance. And a pretty big topic at this moment, before you go to prod, is also being responsible about your AI. So that includes red teaming, so actually inviting people to break your app, but also automated red teaming, so making sure that you regularly run all of those lessons that you learned before. In a car, you're also going to have to think about some other safety aspects, as you can imagine. But how you can get started with this is, pick up one of the frameworks for automated red teaming, organize a little hackathon where people try to break your app, incorporate them into your automated red teaming again, protect your app with things like, the moderation filters that are coming through Azure OpenAI, and I think also some of the other frameworks help you with that. So some basic guardrailing there. Now, time for some takeaways. So to keep up with this super fast pace of AI, it's even more important to take an iterative approach and to do lots of prototypes. So find the smallest way to test the core idea that you're looking for, maybe even in isolation from your main app, and then use those learnings in your app. Using a framework can really help you to test this idea very quickly. But to deliver value in the end, you're always going to have to somehow reach users. And this last step will be an endless iteration because the expectations and the technologies change literally every day. Then small prototypes on your laptop are great for demos, but to get even more feedback, you probably want to move to a cloud app. And just adopting some cloud services off the shelf or using some templates can help you really focus on the core concept and to differentiate. Now, what I find personally most exciting is that really today is like the advent of the OOP days, so the object-oriented programming days, because we're programming with language, basically, and all sorts of new patterns are popping up. New ways to test are necessary. Guard railing, retrieval augmented generation, I really see those as basically things that are going to be mentioned in those, like we have the OOP books all on the shelf now. There's going to be another one like that in 10 years, I think. Now, all in all, I'm just super excited what this year will bring in AI. I think it's all multimodal, super fast, going smaller, everything to the edge. Just lots of things happening all at the same time. Now, we're about to take some questions, but before we do that, I'd like to invite you to come to actually talk to us, the TomTommers, but also to our assistant. So we brought the assistant in a cockpit. You can come play with the cockpit and ask it questions. We're on the 5th floor, I think somewhere near MS08. Well, in any case, I hope you do that. Thank you. Okay. All right, it's time to take some questions. In the meantime, get your phones out. We're going to leave this up during Q&A. These are the resources you can check out.
I'm a big fan of voluntelling. Any questions?
There is one from online audience. I don't have a microphone, but I hope you can hear me.
Yeah,
Yes.
we can hear you. We'll repeat it. Okay.
All right, and this is actually for Massi. We have an online user, attendee, Esteban is his name. He really loved the demo that you showed. The question is, when is this available for my car? Like, is this still in a proof of concept phase, or is this already something that you're bringing to cars, like manufacturers, car manufacturers?
That's a great question. So, of course, the real answer is like working on it. So we're not in any production car right now, but this is going to happen no matter what.
Great, thank you.
Question way in the back.
How do you user test something like this knowing that there's like the potential to distract the driver?
Okay, so the question was, how do you user test? And isn't there a lot of possibility to distract the driver, right? So user testing this was my first time ever being there in real life, doing user testing. Man, that was pretty essential, yeah? So things like, is it still listening to me, yes or no? Is it showing the information that I want? Basically, really, there is no alternative for actual user testing. That's what I learned from that exercise. Unit tests and whatever other framework you're using are really not quite enough. You need to also test with real users, and that's for sure. And then also, of course, to see what distracts them in that. What's their reaction when an answer is super long, for instance? Can they give feedback about that? Those are the things we look at. Thank you.
And to add to what Massi was saying, actually.
Yeah, sorry, people. Yeah.
To add to what Massi was saying, actually, laws have existed for years, and I still drive on the streets with a lot of distracted drivers who are on their phones, and that kind of becomes the other distraction. So, it's much better, I think, in terms of me personally being a user on the other side, to have something that's more voice activated and listens to you and has a little bit of intelligence behind it. It's just my opinion as an outsider.
Still not going to improve the driving quality for people. The drivers in Seattle are still going to be terrible, though. Just.
Any other in-person questions? I have a mic back here, too.
I will repeat it.
Okay. I'm curious to know, how is security integrated within here? I want to know how responsible AI or security is integrated
Wow, you're really looking into the future there with the autonomous driving too. I mean, ideally, of course, it's all one experience, right? Oh yeah, right. How do you approach, again, actually, how do you approach the safety, right? And how does this connect to autonomous driving? I'd like to focus on the second half there, because I think we touched on the first half quite a bit. Yeah, I mean, ideally the future, of course, the entire experience is integrated, right? So it starts with maybe your companion app that you have for your car. You're maybe doing some trip planning, sending this to the car. When you get there, the right maps are already loaded into your car, because for autonomous driving, you have much heavier demands on what kinds of maps you need. And then also, the same sensors might be usable eventually also in multimodal AI. And I think there's going to be a lot of interesting things popping up there. So think about, the famous example is, can I park here? And there's some super complicated parking sign. This one went viral on Twitter when basically GPT-4 with vision came out, right? I think you can really just think endlessly about the possibilities once you integrate all these sensors. Great, thanks.
Yeah, that's a great question. I mean, OpenAI came out and basically said GPT-4o outperforms GPT 3.5 Turbo in like all testing, and they've encouraged developers to continue testing. So we're not thinking about replacing models at this stage. We're thinking about how can developers evaluate, similar to Masi talked about looking at different models, comparing models. So a big focus is developer testing. GPT-4o we made available as quickly as we could. It was the first time we launched a model with OpenAI at the same time. And we're just really eager to see what our developers think. Not all benchmarking did GPT-4o beat GPT 3.5 Turbo. So I think it's just going to be a matter of being on this journey together, because we know that OpenAI will continue to release not only iterations of the GPT models, but I'm sure this is a precursor to whatever the next big thing is, right? 20 years of digital data gets us to generative AI. What does 2 years of generative AI data get us to? I think that's the magic question. So I think just continue to test and iterate and be comfortable with a multi-model approach, not just a multimodal approach.
Yeah, there's another online question from John. There is a thing called Microsoft Connected Vehicle Platform, MCVP. Are you in any way integrating with that platform, MCVP?
Okay. Yeah, so we are really close. I mean, look, we are literally standing here right next to each other. So Microsoft and TomTom are pretty close. So we are actually, of course, we are looking at all the ways that the architectures, can play nice. But not all of the car makers will choose such platforms.
Great, thank you.
Questions way in the back.
How have you used Azure's Studio and responsible AI evaluation tools to make model decisions? Have you at all? And this gets back to that previous question up front. Are you looking at any of the NeMo tools that have been released by NVIDIA for things like I/O and performance-based custom model decision-making when it comes to multi-model evaluation?
All right, so how do we make the decisions between which model we pick, and in particular, about the safety concerns, right?
Well, yeah, I was wondering if you've looked at Azure's responsible AI toolkit, any of the other kind of guideline tools for model evaluation.
Right. So we actually have a Microsoft person also connected with our team very tightly, and they're working on some of these aspects. So they actually got us off the ground with some of this red teaming, for instance. Yeah.
A couple of interesting questions from online. First of all, is there any portion of this that's open source? Can we collaborate, help on its development? And the second question is, do you need to buy new hardware, or can I use my existing TomTom?
Oh, two fantastic ones. Open source.
Just reflash that thing.
Flash it.
Just reflash flash that.
Oh, wow, well.
You bought for your parents back in 2000.
Exactly.
Well, I honestly, I haven't thought about the open source part of this yet. Right now, most of it is basically an API, right? So we talked about that it was mostly online, and then on the client side, you need to do the integrations. I mean, it could be a great idea. So if they get in touch, we can maybe discuss that. Can you remind me of the second question?
Do I need to buy new hardware,
New hardware.
or can I use my existing TomTom? That was the second question.
Yeah. Right. Well, so if we would make some of that open source, perhaps the hackers would find a way to flash that onto your existing TomTom.
SLMs will help you get there because you can compress it on a really small device.
Whether the SLMs will fit on a 2020 TomTom device, yeah, I'm not quite sure.
I was thinking 2010, not 2020.
2010. Yeah. No way. Yeah, that's a fun question, but I don't really have an answer for that. Yeah.
Okay, I think that we're almost out of time, but I just wanted to say one thing. First of all, I want to give a round of applause to Masi. I want to thank my colleagues, Mark and Kamala, so much for joining us as experts for their respective areas. I want to give a thanks to Mikhail and Marco for their support behind the scenes. And I want to thank you all. And I want to thank you all in a surprise and delight way. We are in a auto session. We are with TomTom. We have a lot of tinkerers and builders and collectors in the audience. So there's about 50 limited edition Hot Wheels under seats. And if you don't get one, like honestly, I don't know if there may be 50 of you in here, but under seats we have some really cool Hot Wheels cars. If you got one, make a noise.
By the way, if it's not under your seat.
Yeah, look around. We also have some stickers up front as well. But we just wanted to say thank you all so much for joining us, and we're really excited for the future. Thank you, everybody.
Thank you.